You have 7 friends that are working with each other, right? 7 of them, let's call them Roy Biv, right? Their parents probably named them after colors or something, right? Red, orange, yellow. And they pass through a certain space. Let's just call it a room, right? And afterwards, only 2 friends are appearing. What happened to the rest? We're going to use this example to better understand the absorption spectra. Hello guys, and welcome to my YouTube video. Let's start from the beginning. Say Isaac Newton observed that light exists on a spectrum of colors, for example, the rainbow, right? If you're looking at a rainbow, you're looking at a spectrum of colors. That is just white light that has been spread out so that you can see the different fragments. And say Isaac Newton showed us that light is made up of different colors, right? Implying that if you were to split white light, you should see Roy G. Biv. You should see all these different colors, right? And they should all move in the same line. But something weird can happen if you're gonna put a cool gas, right? If you're gonna put a cool gas and you're gonna pass light through that cool gas, you're gonna notice something phenomenal. As you pass light through that cool gas, you're realizing that some parts of the light are missing. You're expecting to see a wavelength at green or something like that, and it's no longer there. Have been absorbed, and a certain process has occurred so that you don't see them appearing in the final spectrum. And we call this type of spectrum an absorption spectrum. That's a past paper that has been asking you to explain the dark lines that you're able to see. So let's go along with it. If you've done shells, you have different shells. If you've done chemistry 1s2, those all symbolize different energy levels that electrons can occupy. Each energy shell is at a different energy level, and this is an important concept for us to grasp, right? So if electrons can occupy different energy levels, think of them as different houses, right? In society, we have probably the lower class, the middle class, the upper class. You know, I didn't create societies like that, but think of that as different classes of people, right? People in the lower class, in the middle class, and then in the upper class. And think of those as the energy levels that electrons can occupy. Okay, so if you have an electron that is in the lower class or that is in the lower energy level, we usually represent this energy level in electron volts. If you pass white light, if those friends come into the house, right? If you pass white light, what's going to happen is that a photon is going to give its energy. So white light consists of photons, right? All the energy is made up of photons that carry the energy with them. So as they arrive to an electron in a certain house, a person in a certain house, they're going to give them energy, right? And as they give them energy, that electron is going to absorb it and say, thank you very much, right? So think of it as money, right? White light is coming with money and giving it to a person in the low house. Okay, and then they're like, thank you so much, right? They can't just stay in the low house. You know, whenever you get money, you're gonna flex, right? And you're gonna upgrade your life, buy a Lambo, buy a Bugatti or something like that. You're gonna flex, right? So an electron is gonna take that energy and it's like, okay, I'm gonna rise up my rank, and it's gonna go to the middle class. Or if it's a lot of energy, it's gonna go to the upper class. So the photon comes with its energy, gives that energy to the electron, right? And an inner shell absorbs that electron, and that electron moves to a higher class. That electron moves to a higher energy, right? And it's very, very important to think of that. But the energy of the photon will be equal to the energy difference in the energy levels. What do I mean? The amount of money that you have been given, right, should be equal to the transition from the lower class to the middle class, right? You can't be given 20,000 and you expect to go to the higher class. The amount of energy that you're given corresponds to the energy level. There's a gap between the middle class and the upper class. There's a gap between the lower class and the middle class. And the gap that's there is the amount of money that you're given, or in this case, is the amount of energy that the photon gives to the electron. So the electron is going to take that energy and is going to be excited, and it's going to move to a higher energy level. But it doesn't last, guys. You've heard issues of lottery, right? People winning the lottery, they get so rich and famous, but over 2 months or something like that, they go broke and they're unstable. That's because they were not used to the lifestyle. Being rich is not just about the money. It's not about the flex, the cars, the houses. It's about the lifestyle, the kind of person that you become. And I know nothing about this, but it's about the kind of lifestyle that you attain. So the electron is not going to stay there for long enough. It's going to be like, no, I can't handle it. And it's going to de-excite, right? It's going to say, I can't live like this anymore. And it's going to skip from that high energy orbital, and it's going to go to a lower energy. And during that whole process, it's going to emit a photon. right? Remember, we gave it money so that it goes to the middle class, and it had all that money. It's like, I'm not happy, I'm not stable, I can't cope, right? And it's gonna be like, no, I'll go back to my lower class. Here's your money back, and it returns that money. In this case, the electron gives back the photon, gives back the energy, and this is very important. And it gives off energy. The photons are emitted in all directions. So if the electron de-excites, it's not going to give back the photon in the exact same manner that it was taken, right? It's going to just throw it away. It doesn't give it back to the owner. It's just going to throw it away, and it moves to that other side, right? So as the photons are just now emitted in the multiple directions, the original light that you're going to get is going to have missing wavelengths, and that sort of explains the absorption spectra. So if a question comes, right, you might have all fun in that, but if Cambridge comes, you're going to give it specific marking points. How are you going to say it? Photon gives energy to the electron. First point, okay, absorbs a photon, right? So a photon gives energy to an electron, or we can say an electron in a shell absorbs a photon. That's the first point. The second marking point, we can then say that the electron moves to a higher energy, right? The electron gets promoted in society, moves to a higher energy, right? That's the second point. The third point, the energy of the photon will be equal to the difference in the energy levels. The amount of money it gets, or the amount of energy it gets, will be equal to the differences in the classes in society. And number three, electron is going to de-excite. It's not going to stay there for long. Electrons are like, oh, I don't like this amount of energy, it's unstable. It de-excites, and it's going to emit photons. But it's not going to just emit photons, it's going to emit the photons in all directions, right? So you had a group of 7 friends. So go back to original idea. You had a group of 7 friends that were entering, right? And they're moving all in the same direction. But what's happening is that inside the room, one person is going to take, or a friend is going to be taken away from the group. Then they're going to be emitted in a different direction. They're going to exit in a different direction, right? One is going to be taken, emitted in a different direction. They're not exactly, different. They just taken and absorbed or emitted in a different direction, so that the final result would be 2 friends that were moving in the initial direction that they were moving in. So that's the whole point of an absorption spectra. You're looking at a spectra like Isaac Newton. You're like, okay, light is made up of different colors, but something is missing. And you're like, okay, something is missing because it has been absorbed and it has been emitted in a completely different direction. That sort of explains the absorption spectra and quantum physics, and a little bit of this applies in astronomy. So thank you guys for watching, and I'll see you in the next one.